This is the first of 7 videos based around the concept of index notation. So this one here is going to introduce you or revise the concepts of index notation, and from there we'll take it into the index laws themselves. So our learning goal with this particular presentation is that we understand what standard form is for a number and what index form is for a number, and how those two representations are interchangeable. That means we can switch between the two of them. So index notation is a product of simple multiple identical factors. So we'll just highlight that. Multiple identical factors. So the reason we do it is that it's an easier way to represent large numbers. So in this case, 6 to the power of 4 means we're multiplying the base here in blue by itself 4 times. 6 by 6 by 6 by 6. And that gives us our resulting number. So there are 3 different representations of the same number. So the blue number is called the base. The red number is called the power or index. We have another name for that called the exponent, which is E-X-P-O-N-E-N-T. Let's see if I can write that in here. E-X-P-O-N-E-N-T. So they're 3 names for the same thing. And then we have the expanded or factor form is what that's called, because it's made up of factors. And finally, the basic numeral or number. So they're the parts that you must be able to identify. So with algebra, the same processes apply. So that was a numeric example, but with algebra we have the same number of bases. So there's a simple notation here in the middle. These 3 dots mean this pattern continues forever, for infinity. So A times A times A times A, and it just keeps going. So we can represent that situation very quickly and simply by using A to the power of n. So what the n means is, because that's our power or exponent, or index, it means multiply the A by itself that many times. And because n is unknown, it could be any number of times. So n indicates the number of times we multiply the base by itself. So here's some examples to get us started. Let's express 360 as a product of powers of prime factors using index notation. So let's start. Firstly, what are we trying to find? We know the number 360, so that's the first part. And we want powers of prime factors. So prime numbers are those that only have 2 factors, that is, itself and 1. Examples are 2, 3, 5, 7, 11, etc. So let's look at that. There's a couple of ways we can do it. This is the first way. We're just going to start by finding 2 factors of 360. Now you can use any factor. You can use 2 times 180 to start you off. I like to choose some bigger factors that I can see first because it speeds the process up. So the first factor is 6, second factor is 60. 6 is not a prime, it's a composite number, that is, it has multiple factors, and 60 is a composite number. So we can break them down further. So 6 breaks down into 2 times 3. Now 2 and 3 are prime. 60 breaks out into 6 and 10. You could have gone 4 and 15 if you like. So we can break the 6 and the 10 down here, the purple and green, into two other factor pairs. So we have 2 times 3, we've already done. 6 breaks down to 2 times 3, and 10 into 2 times 5. Now we've got multiple numbers that are recurring the same, again and again. So we can use index notation to reduce that into something smaller. So I've color-coded these again. 2's in red, 3's in blue, and 5 is an orange-yellow. So because multiplying by 2, 3, lots of 2, it's 2 to the power of 3. Because we have 3 multiplied by itself twice, it's 3 squared, and then 5 there. Now don't forget, if there's no power mentioned, that means the power of 1. Now we don't write that to save ourselves some time. Here's an alternative method. Now I've included the website here for a link that does this process for you with the factor tree. So that's all I used. So once again, type in your factor and it brings up the factor pair. Now you're familiar with factor trees from grade 6 or 7. And it gives us the same results here where we can come up with the answer. So hopefully from this lesson, this short lesson, you understand how to represent numbers in standard form and index form, and how to change between the two.